In this video, we are going to look at trigonometric functions of angles and standard position. Before we get into some problems, let's revisit the unit circle and write down a lot of information that we've already looked at with the unit circle. So again, a unit circle means that this circle has a radius of 1. So this point here at A is 1, 0. This point up here is 0, 1. This point over here is negative 1, 0, and this point down here is 0, negative 1. We also have our initial arm along the positive x-axis, our terminal arm joining the origin to the point P on the circle. We can form a triangle by dropping the line down to the x-axis. We know the x value will be cos of our angle, and the y value will be sine of our angle. So that point has coordinates cos theta, sine theta, because it's x comma y. We also looked at angles. We are going to write our angles going in the positive direction. So here is 0 degrees, up here is 90 degrees, over here is 180 degrees, and down here is 270 degrees, and then back to 360 degrees. So we have talked about sine theta and cosine theta, but we have not talked about tan theta. Tan theta, we know, is the opposite over adjacent. And just like when we looked at sine and cosine for the first time in the unit circle, from this angle, the opposite is our y value, and the adjacent is our x value. So it's y over x. And we know that our y value for that angle is sine of that angle, and our x value is cos of that angle. So we now see that tangent of our angle is equal to the sine of our angle divided by cosine of our angle. However, there is a restriction because there is a denominator. Our denominator cannot equal 0, so here cos cannot equal 0. So now we are going to use the unit circle to find values of sine theta and cosine theta and tangent theta without a calculator. So for angle 0, we know we are here where the coordinate is 1, 0. So I've written that on the side, 1, 0. Sine, we know, is our y value. So what we will do is take the y coordinate from that point, which is 0. So sine of 0 degrees is equal to 0. Then cos, we know, is our x value. So we will look at the x coordinate of that point, which is 1. So cos of 0 is 1, and you can check that with your calculator. Tan, we know, is sine divided by cos for that angle. Here at 0 degrees, sine is 0, cos is 1. 0 divided by 1 is 0. So tan of 0 is 0. At 90 degrees, my y value is 1, so sine of 90 is 1. Cos of 90 is 0. To get tan, I'm going to divide my sine value of 1 divided by cos 0. Again, you cannot divide by 0, so we say that this is undefined, which means that there is an asymptote here if you were to graph the tan function. The next coordinate is at 180 degrees, negative 1, 0. Sine is y, so 0. Cos is x, negative 1. Tan is 0 divided by negative 1, which is 0. At 270, the coordinate is 0, negative 1. Sine is my y value of negative 1. Cos is my x value of 0. And again, I will divide -1 divided by 0, which is undefined. And finally, at 360, the coordinate is the same as it was at 0 degrees, so all the values are going to be the same. 0, 1, and 0. So we just found values for sine, cos, and tan for angles that lie on the arms of the axes, all without a calculator. So this could be on the non-calculator part of the test. Next, we're going to look at what happens when angles fall in between the axes. So we are going to look at each quadrant at a time. So first we will look at quadrant 1, which is up here. So in quadrant 1, we know our sine value is positive because our y value is positive. We know the cos value is positive because our x value is positive. So I'm going to say that sine of any angle between 0 and 90 is positive. Cos of any angle between 0 and 90 degrees is also positive. Tan is sine divided by cos. A positive divided by a positive is positive. Next, we are going to look at a triangle in quadrant 2, which is over here. So I'm going to draw a right angle triangle in that quadrant. So now we see that sine is positive because our y value is positive. Cos is negative because our x value is negative. So in the quadrant 2, we're dealing with obtuse angles, which we've looked at already, and we know that sine is positive and cosine is negative. So that means tan is going to be negative because a positive divided by a negative is negative. So now we're going to go bigger than 180 and go to quadrant 3, which is any angle between 180 degrees and 270 degrees in here. So I will draw a triangle. We can see that the y value is now negative. So sine theta is negative, and the x value is negative, so cos theta is negative. So sine's negative, cos is negative, so that means tan is positive because a negative divided by a negative is positive. And finally, I'm going to look in quadrant 4. So I drew this triangle here. Y is negative, so sine theta of any angle when theta is between 270 and 360 is negative, and cos is positive because our x value is positive. So for any angle in here, cos of that angle will be positive. So sine is negative, cos is positive, a negative divided by a positive is negative. So tan is negative. So just as sine theta has two solutions for our angle theta between 0 and 180 degrees, all primary trig functions, meaning sine, cos, and tan, have two solutions for that angle theta when we extend our unit circle from 0 to 360 degrees. To help us remember where each ratio is positive, we use the cast rule. So the cast rule, you see it's spelled C. We start in quadrant 4, A, S, T. So we go counterclockwise, but we start in quadrant 4 with the C. So the C means that the cosine ratio is positive in this quadrant. Only the cosine ratio. A in quadrant 1 means that all of the ratios, sine, cos, and tan, are positive in quadrant 1. S means that only the sine ratio is positive in quadrant 2. And T means only this tan ratio is positive in quadrant 3. So each ratio is positive twice, in the corresponding letter and in A. So tan is positive in quadrant 3 and in quadrant 1. So we are going to look at a couple examples. The first example says determine the values of cos, sine, and tan for 170 degrees and illustrate our solution. So using a calculator, I found that cos of 170 degrees is negative 0.9848, sine of 170 is a positive 0.1738, and tan of 170 is negative 0.1763. So I found all those values simply by using my calculator. Tan, though, I could have found by dividing sine divided by cos. Positive over negative means that tan is negative. So to illustrate this on my unit circle, what we are going to now get in the habit of doing is writing CAST. We need to draw 170 degrees, which is about here, almost at 180, not quite. So what that means is, because of our cos value is negative 0.984, that means that is about here, 0.9848. Remember, cos is x, so along our x-axis, that point went to the left, 0.9848. Sine is positive 0.1738, so that is up here. It went up 0.1738. You can tell I'm not drawn to scale. So again, that means the y value here, I went up 0.1738, and our x value is negative 0.9848. And we are in the S quadrant, so that means only sine is positive, which we found in our calculator. Sine was positive. The other two ratios were negative in this quadrant. So we are now going to apply that knowledge to solve trig equations. We are asked to find all of the angles between 0 and 360, that when you take sine of the angle, you get 0.66. So we know there are going to be two solutions, because here sine is positive, our ratio is positive. Because it is positive, I'm going to highlight that. I'm going to highlight the sections that my solutions will be in. I will have a solution here, or S, because sine is positive in the S quadrant, and all ratios are positive in the A quadrant. So what I'm going to do is draw a line, a triangle in the A quadrant, and I'm going to draw a triangle in the S quadrant. To find my angle, I'm going to take the inverse of sine of my ratio, so inverse of sine of 0.66, and I find my calculator, that my angle is 41 degrees. I'm going to call that my reference angle. My reference angle is the angle I get with my calculator. 41 degrees lies between 0 and 180, so it is this solution here. So my reference angle is a solution. It may not be, but in this case it will be. We will see in another example when it is not. So that means this angle here is 41 degrees. So that means over here, this angle is also 41 degrees. So to find my second angle, what I want is from my initial arm over, what is that angle? So my second angle is 180 minus 41, because I almost went over 180 degrees, but I was 41 less than that. And also we saw from the other lesson that the acute and then the obtuse angles add to 180. So this angle is 139 degrees. So therefore the solutions are 41 degrees and 139 degrees. And you can check with your calculator. Sine of 41 should give you 0.66, and sine of 139 should give you 0.66. In the second equation, we want to find the angles between 0 and 360 that satisfy cos of that angle is equal to negative 0.76. So our ratio is negative. Our cos ratio is negative. So I'm going to identify where my solutions will be. Because we know cos is positive and C in quadrant 4 and an A in quadrant 1. That means cos is going to be negative in quadrant 2 where S is, and in quadrant 3 where T is. So I will draw my triangles in those two quadrants. And now I'm going to use my calculator to calculate my reference angle. However, because my ratio is negative, I do something a little bit different here. I actually ignore the negative to find what the angle is if cos was acute, if the ratio was positive. And I find that the reference angle is 41 degrees. So that actually is this angle here in my A quadrant. It is actually not a solution because it's not in the right quadrant. However, it's going to allow me to find my other solutions. If this angle in here is 41 degrees, that means this little angle is 41 degrees and this little angle is 41 degrees. So that's going to allow me to find my two solutions. So that is very important. I did not put the negative in my calculator to find this angle. I used the negative to identify which quadrants my solutions will be in, and now I am ignoring it. So to find my actual solutions, my first one is going to be 180 take away 41 degrees, which is 139 degrees. And I got that from starting here. I went almost 180, but less by 41. And then my second solution, I'm going over 180 full, and then I'm adding 41. So my second solution is 180 plus 41 degrees, which is 221 degrees. So the solutions that satisfy this equation are 139 and 221 degrees. And again, if you were to put that into the angle, you will get this negative 0.76. If you were to put 41 into your angle, you would get positive 0.76. If you forget and you make a mistake and you put in the negative into your calculator, you will get the answer of 139 degrees. So you will get one of your answers. However, by getting 139 degrees, it's a little bit harder to get to the 221 degrees. It's possible, but finding your reference angle will easily bring you to your two solutions. And finally, we are going to solve tan theta equals positive 2.73. Tan is positive, so my solutions are going to be in quadrant 1, where they are all positive, and quadrant 3, where tan is positive. So using my calculator, inverse of tan of 2.73 is 70 degrees. So that is my reference angle. So if I were to draw that, it would be up here, which is where our solution will be. Therefore, this angle is a solution. And then my other solution is in quadrant T. So I'm going to draw another triangle in the T section. So to get to this angle, I'm going to go over 180 degrees, and then I'm going to go over 70 more, because the little angle inside the triangle is 70 degrees. So that is 250 degrees. So then I will state that my solutions are 70 and 250 degrees. So in short, your steps are to find the reference angle, and then you use the reference angle and the CAS rule to find both solutions between 0 and 360. You could have more solutions if you go further than 360. And remember that the reference angle is the angle that lies between the line and the positive x-axis. So what we do is we draw this bow tie. If this is your reference angle, it is the same as this angle here, and this angle here. And then what we do is we simply subtract that angle from 180 if our answer is between 90 and 180, or we add the angle to 180 if our answer is between 180 and 270, or we subtract that angle from 360 if our angle is between 270 and 360.